Hello everyone, welcome to my YouTube channel. So today's lecture we are going to solve other PYQs from the Newton's law of motion. In the previous 4 videos we have already solved Newton's law of motion till 2011. Now in today's lecture we are going to solve other PYQs from 2012 to 2016. So already we have covered 1D motion, 2D motion, relative velocity concept, and river swimmer problem, rainman problem. All the PYQs till now we have completed. And this chapter, after this chapter, we are going to start work power energy chapter, and then we also start second 12th class PYQs. And I also thinking to start to solve IIT problem so that you get helpful for your preparation. So I start this lecture. I hope you are doing very well and you are enjoying my lectures. So this question from 2012. A car of mass m is moving on a level circular path of radius r. If mu s represents the static friction between the road and the tires. So this is and the tires of the car. The maximum speed of the car in a circular motion is. So actually this question, see, this is not any banked road. This is only horizontal circular road. A car of mass m is moving on a level circular road. Level means they are not banked. They are not banked. Mu s represents the static friction. Suppose here the car is moving, right? And a car of mass m, their mass is m, and this circular has a radius r. Radius r. If mu s represents the static friction between the road and the tires of the car, the maximum speed of the car in circular motion. Up here you see that centripetal force is provided by the frictional force. Here you see this body has a normal reaction acting upwards, mg force acting downwards, but friction force here, friction force, this limit maximum, here you see now this, they say the maximum speed, the maximum static friction, that is our limiting friction that providing the centripetal force, right? So what I say that on a level circular road, friction provides the necessary centripetal force, So here you see that necessary centripetal force is provided by friction, and that is maximum friction, that is maximum static friction is limiting friction, that is equal to mb square by r. So maximum limiting friction, that is equal to mu s into normal, that is equal to mb square by r. And we know that normal reaction is equal to, this is our equation first, and normal reaction is equal to mg, this is our equation second. Putting, just 1 minute, putting equation second in equation first, so we get mu s into normal is mg, that is equal to mv square by r. M cancel, so this comes out to be v square is equal to mu s g r. So this maximum speed, that is going to be mu s g r, mu s g r, sorry, mu s g r. So which option is going to be mass? Option mu s g r. So option D is correct. Option D is correct. Now I proceed for the next question, and this question is also from circular motion. A car of mass 1000 kg negotiates a banked curve of radius 90 meter on a frictionless road. If the banking angle is 45 degree, the speed of the car is. So this is also like general formula. We have derived this. देखो. So what this question saying that a car that has a mass 1000 kg is banked. So banked means like this is moving like a some angle. This angle I say theta. At general I derive this relation. So here you see this. So this I make car, and here the tires is there, right? So normal reaction acting perpendicular and weight mg acting. Just 1 minute, I use different colors so can easily visualize it. mg force acting, mg force acting downwards, mg force acting downwards. So this angle is theta, so this is also theta, right? And here this surface is frictionless. A car of mass 1000 kg means car has a mass that is 1000 kg is negotiate a bank curved road of radius 90 meter on a frictionless surface. If a banking angle is 45 degree, then they are asking speed of the car. Speed of the car. Here you see that if I draw this, see, this is theta. Sorry. So if I resolve this component, this is also theta. So this is n cos theta, and this is n sin theta. And centrifugal force acting away from it, that is mv square by r. mv square by r. So here you see that n cos theta that is equal to mg. This is centrifugal force, so that is acting away from the mg. And n, this is our equation first. And this is our n sin theta that is equal to mv square by r. This is equation second. What I do? Divide equation second by equation first. We get tan theta is equal to v square by rg. This is our formula. Now we want, this is our standard formula. You can also remember this, or we can also write v is equal to rg tan theta. rg tan theta. So v is equal to, radius is, how much they have given radius? Radius is 90 meter, and g value they have given 10, or otherwise we have to take it. Let me take 10, and 10 45 degree. We know that 10 45 degrees 1. So this is 900. So this comes out to be 30 meter per second. 30 meter per second. So this answer is option B is correct. Option B is correct. A person holding a rifle, mass of a person and rifle together is 100 kg, stands on a smooth surface. and fires the 10 shots horizontally in 5 seconds. Each bullet has a mass of 10 gram with a muzzle velocity of 800 meter per second. The final velocity acquired by the person and the average force exerted on the person. What is going to happen? See this question. So here the person is there. Here the person. Here the person holding this gun. A person holding a rifle. Mass of the person. Mass of the person and the rifle together is that is 100 kg. 100 kg. Stands on a smooth horizontal surface and fires 10 bullets. They fire 10 bullets in 5 seconds. Each bullet has a mass of 10 gram, means 10 to power minus 2 kg, with a muzzle speed of, the speed is 800 meter per second. The final velocity acquired by the person. They are asking what is their velocity acquired by this person. This I say v2, this I say v1. So just apply conservation of, there is no external force, external force acting on the system. So net momentum is conserved. So what I say, P initial is equal to P final. That is, initially both are at rest. After that, what going to, this blade, this is moving with V1 plus mass of this person and bullet minus, and here 10 bullet is moving, and M and here I write feet, right? So here you see that here 10 bullet, their mass is 10 ki power minus 2 and their speed is 800. That is, mass of the bullet and person is 100 kg minus 10 into 10 ki power minus 2, and V2 we have to find. So this comes out to be 80, because 10 ki power minus 2 going to be cancelled, so left 80 plus 100 and minus, this is 0.1 approximately, that is, so V2 comes out to be, here you see that if I send this, and this is negligible as compared to this, so I ignore this. So this is 100, V2 is equal to 80. So V2 comes out to be minus 80 by 100. So V2 comes out to be minus 0.8 meter per second. 0.8 meter per second. So which option is going to be match? Acha, now we have also find average force exerted on the person. So average force exerted, now we have to find average force exerted on the average force exerted on the person. On the person. So we know that average force, that is equal to change in momentum in time interval. So here you see that in 10 seconds we have shot 10 bullets. So that amount is equal to the whatever the force we are exerted on it. So that is N M U Y delta T. So here 10 bullets I put 10 to power minus 2 and their speed is 800 divided by time interval 10 seconds. So here you see just 1 minute. 5 second time is 5 seconds. Okay, sorry. This is the mistake I do it. I so many times calculation mistake only happen. 10 to power minus 2 and this 2 going to be cancelled. So this is 80 by 8. So average force is comes out to be that is 40 14 Newton. No, this is 16 Newton. Sorry. So 16 Newton, any option 0.8 and 16 Newton. So option B is correct. Option B is correct. So option B is correct. So I proceed for the next question. This is also a very good question. A car is moving on a circular horizontal track. Circular horizontal track means there is no bank road of radius. Radius they have given 10 meter with a constant speed. Speed is 10 meter per second. 10 meter per second. And then after that, a bob is suspended from the roof of the car by a light wire of length they have given 1 meter. The angle made by the wire with the vertical. Angle made by the wire with the vertical. It is like this situation. They are asking this. Sorry. So they are asking this. Sorry. They are asking this vertical angle. Here the bob is going to be standing and they are moving here and there. So here you see this bob. I make different colors so that it is easier for you to understand. Not like this, some different color. That's fine. So this is mg force acting. This bob has a mass m, and here you see that this bob has a tension T acting here. This angle theta, so this is also theta. So if I resolve this, so this is T cos theta. Here T sin theta. So here I say T cos theta is equal to mg, and here T sin theta. This is our equation first. T sin theta providing centripetal force mb square by r. mb square by r. mb square by r. So this is our equation second. So what I do, I divide this equation second by equation first. So this comes out to be tan theta is equal to v square by rg. So we have to find this vertical angle. This they have already given speed. They have given tan square means 10 into 10. Radius is also 10. G is also 10. So this comes out to be 1. So theta is equal to 45 degree or pi by 4. So this we can say that theta is equal to pi by 4. Pi by, sorry, pi by 4. So which option? Option C. Sorry. Option C is correct. Option C is correct. I proceed for the next question. See. The upper half of an inclined plane of inclination theta is perfectly smooth, while the lower half of a is rough. A block starting from rest at the top of a plane will again come to rest at the bottom. If the coefficient of friction between the block and the lower half of the plane is given by. So in this question, just to make the diagram, first this is our inclined plane, right? So here, from here to here, half part, this I say L by 2. This is smooth. And this part, sorry. This L by 2 part is rough, right? This block is going to be started from here, right? And this block reach to this position, right? So here you see this is P. This angle is theta. This angle is theta. So here you see that this block has a normal reaction acting, and here mg force acting towards the center. So this angle is also theta. This is theta. So this is mg cos theta, and this is mg sin theta. Here mu is 0. Here mu does not equal to 0. Here mu is equal to 0 till this position. So what we do for smooth part? What we do for smooth part? For smooth part, we apply equation of motion v square is equal to u square plus 2as. We know that v square is equal to initial speed is 0 because they are released. Released means initial speed is 0 plus 2 times acceleration, I say a1, and distance I say l by 2. So here you see that this v square is comes out to be a1 into l. This is our equation first. For rough part, what I do rough part, again apply equation option v square is equal to u square plus 2as. So for rough part, you see that final velocity becoming 0. That is equal to initial speed is, that is v square plus 2 times acceleration a2. Distance is l by 2. So this v square is comes out to be minus a2l. So here you see that equation first and equation second we can compare. So this comes out to be a1 into l, that is equal to minus a2 into l. L going to be cancelled. So here you see that this is a1 is equal to minus times a2. This is our master equation. Sorry. Now the main task for smooth part, acceleration we know that is a1 is equal to g sin theta. For rough part, for downward motion, downward के लिए what is downward, this going to happen as g sin theta minus mu cos theta. So these two equations we are using here. So here you see that a1 is basically G sine theta. Just 1 minute. So here what I do, A1 is G sine theta, A2 is minus times G sine theta minus mu cos theta, mu cos theta. Here you see G going to be cancelled. So here G cancel. So sine theta, that is equal to minus sine theta plus mu cos theta. If I send sine theta that side, so this become 2 sine theta is equal to mu cos theta. So here they are asking mu value, right? So mu value, if I send cos theta that side, so this become mu is equal to 2 tan theta. Mu is equal to 2 tan theta. So which option is going to be match? Mu is equal to 2 tan theta. Option first is correct. Option first is correct. I proceed for the next question. I hope these are very good question and standard question. An explosion breaks a rock into 3 parts. So what is the condition is here? I just make the diagram so that you can easily understand. This is a initially boom. Then after that, what going to happen? They breaks into 3 parts. Right? So they break into 3 parts. So they move. So if they break into 3 parts, so they move in this way that two definitely move perpendicular to it. Two vector will move perpendicular to it, and the third vector will move like that कि their net momentum is 0. So their resultant is comes like this, and this going to be cancel the net momentum. The net momentum going to be cancelled. Just 1 minute. Third vector move in this way that their net momentum going to be cancelled. Right? So here what they have given, explosion breaks a rock into 3 parts in a horizontal. Two of them go of right angle to each other. The first part is moved with 1 kg. 1 kg with the speed of 12 meter per second. The second part 2 kg move with 8 meter per second. If the third part is moving with the speed of 4 meter per second, they are asking M3. So here you see that their momentum, this is momentum is 12 kg meter per second. Their momentum P2 is 8 into 2, 16 kg meter per second. So P net is comes out to be 12 square plus 16 square. So this comes out to be this. So this comes out to be P net is comes out to be root 400. So this comes out to be 20 meter per second. This net momentum is equal to, this P net is equal to third for conservation momentum, conservation of momentum. This P net is 20 is equal to M3 into 4. So this M3 is comes out to be 5 kg and 3 comes out to be, comes out to be 5 kg. So option D is correct. Option D is correct. Option D is correct. Now this question is also very good. Three blocks with the masses M, 2M and 3M are connected by string as shown in the figure. After an upward force F is applied on the block, the masses move with constant speed. This is the key point. Constant speed. So what is the net force on the block of mass M? We know that if velocity is a constant, so acceleration we know that is dv by dt. So acceleration is 0. If acceleration is 0, so their net force in any of the system is force, we know that is mass into acceleration. So their force is always, net force is always 0. Net force is always 0. So this is like tricky question. They will confuse you how they using. So option C is correct. Option C is correct. So this is also a very good question. A balloon with the mass m is descending down with an acceleration a, where a is less than g. How much mass should be removed from it so that it starts moving up with an acceleration? So it is like this situation. First, a balloon with the mass m is descending down, means they are coming downwards with an acceleration a. How much mass should be removed so that it starts moving upwards? So I have to remove some mass, that I say m dash, so they starts to move upwards. So mg force acting downwards, upthrust force acting upwards. When in this also mg force m minus m dash into g, and here upthrust acting upwards. So just write equation of motion for first condition. First condition, F net is equal to mass into acceleration. So here they are coming downward. So mg minus F thrust is equal to mass into acceleration. So F thrust I write as mg minus. This is our equation first. Now for second condition, you see that F net, again apply equation of motion, F net is equal to mass into acceleration. So here you see that their block is, now this balloon is moving upwards. So we apply equation of motion, F thrust minus m minus m dash into g, that is equal to m minus m dash into a. Now the thing is that F thrust, this is our equation second. Putting equation, just 1 minute. Putting equation first in equation second. So we get F thrust value is m g minus a, that is minus times m minus m dash into g, that is m minus m dash into a. So here if I multiply mg minus ma, here if I multiply mg plus m dash g, here if I multiply ma minus m dash a. mg going to be cancel, right? So here what you see that we have to find m dash, right? M dash we have to find. So next task, if I ma I send that side and right mg here. Okay, so m dash comes that side and ma go that side. So here you see that if I take m dash common, so g plus a, this is, and this ma and this ma, this become 2ma. So here you see that m dash is equal to 2ma upon g plus a. 2ma upon g plus a. 2ma upon g plus a. So option A is correct. ma, sorry, this comes out to be option first is correct. Option first is correct. So I proceed for the next question. This is 2014 question. The force F acting on a particle of mass m is inclined by the force inclined by the force F is acting on a particle of mass m is indicated by the force time graph as shown in the figure below. The change in momentum of the particle over the time interval 0 to 8 seconds. So they are asking change in momentum. So we know that force is basically dpy by dt. If I have to find dp, that is force into dt. If I do the integration of this area under the curve, give the change in momentum. So we have to find this area. So here you see that is change in momentum, that is 4 area. 1 2 3, first area plus second area plus third area. So change in momentum, that is equal to area of triangle 1 upon 2 base into height. 1 upon 2 base into height is 6. Area of triangle 2, and this is area, this comes out to be negative. Here you 4 minus 2 2, and minus 3 minus 0 minus 3. So this comes out to be minus 6 plus 4 minus 8 minus 4 4. 4 into 3 12. So this comes out to be 2 going to be cancelled. So change in momentum, that is 6 minus 6 plus 12. So that is change in momentum is comes out to be 12 Newton second. 12 Newton second. So option C is correct. Option C is correct. So I proceed for the next question. This is also 2014 question. So what this question? System consists of a three masses m1, m2 and m3 connected by string passing over a pulley P. The mass m1 is hangs freely, and m2 and m3 are on a rough horizontal level. The coefficient of friction is mu. The pulley is frictionless and of negligible mass. The acceleration of the mass m1 is. They are asking acceleration of the mass m1 is, right? So here you see this. Can I make the diagram of it? Net force here we can also make in this way. The downward acceleration of mass m1 is downward acceleration of this mass m. Just make free body diagram of m1 is. Here you see this is m1g, here t acting. So here you see that every block are attached to the string, so they move with a common acceleration, right? So I say that the common acceleration a is equal to f net divided by m total. So here you see that f net, I say, for this m1g force acting, for this m2 friction force is acting, for m2 friction force that is acting only, that is mu g, right? And in the similar way for third body also, mu, see this, just 1 minute, mu m2 g. For m3 also, mu m3 g, mu m3 g. So here acceleration, you can see that these are acting downwards, they are in the direction of acceleration, but these are acting opposite to the direction of acceleration. So that's why this comes out to be negative. Mu m2g minus mu m3g divided by total mass m1 plus m2 plus m3. And here they are saying that the mass are same, m1 is equal to m2 is equal to m3. So acceleration is comes out to be mg minus mu mg minus mu, that I say that this is equal to mu mg divided by 3m. So then after that, here you see that if I take m common, so they're going to be cancelled. So g, and also I take common mg, if I take common, so 1 minus mu divided by 3m. So acceleration is comes out to be g 1 minus 2 mu divided by 3. This comes out to be, so which option is going to match? G 1 minus 2 mu by 3. So option C is correct. Option C is correct. So it proceed for this question. This question is also very good question. This paper is going to be cancelled in Karnataka, I think so. A block A of mass m rests on a horizontal table. It is like this situation. A block of mass m1 rests on a horizontal table. A light string connected to it passes over a frictionless pulley at the edge of the table, and from its other end another block B, another block, this is block A, this is block B, another block B of mass m2 is suspended. The coefficient of kinetic friction between the block and the table is, that is mu k they have given. When the block A is sliding on the table, the tension in the string is, they are asking the value of T is. So they are attached to the same string. So what, just write equation of motion for this. This is m2g, this is T acting. Here I make different color so that it is easier for you. This is T acting, this is also T acting. Here Fk friction force acting. And I assume that the net acceleration is downward direction. So make equation motion, that is m2g minus T, that is equal to m2a. This is equation first. Now I write equation of motion for m1. So T, here you see that their acceleration is in this direction. So T minus Fk is equal to m1a. So T minus Fk is mu k into normal I say m1 g, that is equal to m1a. This is equation second. They are asking tension value. So what I just adding equation first and equation second, we get So m2 g minus mu k m1 g, that is equal to m1 plus m2 into a. So just 1 minute, they are asking tension in the string. Okay, so from here I got the value of t. Otherwise there is also one method. What you do, not adding, you subtract these equations, so you don't have to do more calculation. Subtract. देखो फर्स्ट इक्वेशन आ रहा है t minus mu k m1 g, that is equal to m1 a, and second equation I write minus t plus m2 g, that is equal to m2 a. So what I do, I subtract this equation, so minus this minus this minus, so this become minus minus plus, that is 2t. Here minus minus comes, so this become, if I take g common, so here comes out to be m1, just one, m2 plus mu k m1, that is equal to m1 minus m2 into a, right? But the main thing is we have to find the common acceleration, only then we can give the answer of it. So this is equation third. So now I added equation first and equation second. So then if I add it, so t cancel, so left is m2g minus mu k m1g, that is equal to m1 plus m2 into a. So here a values comes out to be m2g minus mu k m1g divided by m1 plus m2, right? So then after that put this value here, so 2t is equal to g minus m2 plus mu k m1, that is equal to m1 minus m2, and here m2g minus mu k m1g divided by m1 plus m2. So now you can solve it. This is only a calculation, not any required. Just a concept is this. Now you can solve the calculation only and you get the answer. The main thing is you can write this equation of motion or not. If you able to write these equation of motion, after that only the calculation is required. You can do it, right? I hope these are good and you are feeling comfortable, and we have done till 2015 question. Now our next part we are going to solve other PYQs from the Newton's law of motion. I hope you are able to understand approach which I am using, and if you have any doubt or if you are feeling the way I am approaching is not comfortable, you can comment or you can message me personally, or if I'm doing any mistake in my calculation you can also correct me. I hope these videos are quite helpful and these videos make your preparation booster in your journey. I hope we will meet in the next video very soon. Goodbye. Keep up.